Hey everyone, a very good afternoon if you are joining us from Rome, and a good morning and good evening if you are joining us from a different time zone. I welcome you to this session on Azure Durable Functions. My name is Vaibhav Gujral. I work at Capgemini as a director in their Microsoft Cloud Center of Excellence. I'm based out of Midwest US. I'm stay in Omaha, Nebraska. I've been awarded Microsoft Azure MVP, and with that, let's get started with our presentation. Before we jump onto the presentation, would like to thank our sponsors, certainly Microsoft, Avanade, and others who have made this conference possible. Thank you all the sponsors. With that, let's get started with the presentation. This is a quick 40-minute session in which I intend to talk about what is serverless, what are Azure Functions, what are some of the challenges that you can face when using Azure Functions, and how durable functions solve those challenges, and what are some of the patterns you can implement using durable functions. With that, to to le- to level base everyone at the same level, I wanted to touch upon different service models to give you a context. Back in 90s, there used to be bare metal machines that used to run all our workloads, where as a consumer we were responsible for managing everything from networking and infrastructure layer to our application and code. Then came the virtualization wave, where we started using virtual machines, which brought portability, where we can share our infrastructure, virtualize the infrastructure using hypervisors, and then run our applications and codes on that. And then came app services with the advent of Microsoft Azure, which was a platform as a service through which we can run our application and code, and the underlying layers were managed by cloud provider, namely Microsoft in this case. And lastly, serverless functions, which is the serverless offering from Microsoft, where we can provision and run our unit of code as functions, and rest everything else is managed by Microsoft. So before we jump into Azure Functions and what are some of the capabilities that they bring in, wanted to talk about what is serverless. I believe many times people get confused when they talk about serverless. It essentially doesn't mean that there are no servers. Rather than that, you should think of it as less of servers. Basically, all the infrastructure layer is abstracted away from you, and you only worry about deploying and running your code. And some of the examples certainly is Azure Function, which we are going to talk about in today's session, but AWS Lambda and Google Cloud Functions are another example of serverless. And so what are Azure Functions? Azure Function is a serverless compute service offered by Azure that can run your code on demand. You can call these small pieces of codes as functions. Just think that if you can write the code you need for the problem at hand without worrying about the whole application or the infrastructure to run it, how great that would be. Moreover, you can deploy these pieces of code independently and execute those on demand. Now, Azure Function provide out-of-the-box templates for some of the most common scenarios that we can come across daily as a developer, like connecting to a storage, image or video processing, exposing HTTP APIs, IoT use cases, running a script or code in response to an event, or so on. Now, Azure Functions come in pretty handy in these scenarios. Further, you can share these functions across your applications, and developers' productivity gets a boost. Lastly, I assume if you would have worked on Azure Web Apps, you would have also worked on web jobs, which allowed us to write background tasks in same context as a web app or an app service. So think of Azure Function as a serverless evolution of Azure Web Jobs. In fact, if you will go and check out the Azure Functions SDK, you will be surprised to see that it essentially utilizes Azure Web Jobs SDK. Here are some of the key features that Azure Functions offer. It does support a choice of languages, including C Sharp, JavaScript, Java, PowerShell, Python, TypeScript, etc. It does support NuGet and NPM support. You can utilize OAuth for identity management for your HTTP triggered functions. We'll talk about triggers shortly. Since it's part of Azure ecosystem, it does support seamless integration with other Azure services. You can develop these Azure functions in multiple languages, meaning your teams can have multiple skills and they can use their own existing skills to develop these Azure functions and integrate these Azure functions to work together, which makes your development environment quite flexible. And the best part here is that you only pay per use under the consumption plan, meaning you only pay for the compute and network resources for the time your code is executed. And if you don't execute your code whole day, you don't end up paying anything for the whole day. Here's a quick snapshot of the current support for different languages. This is supposed to change with time, so I have provided a link down there so that you can go and check the latest support for different programming language and their versions. Since functions is a part of Azure ecosystem, as I was saying in one of the earlier slides, they can be integrated easily with many Azure services and also several third-party services. Any of these services can either trigger a function execution or they can serve as input or output for your code. Uh, as you can see on this slide, Azure Functions can be integrated with Azure Cosmos DB, Event Hub, Event Grid, Service Bus, and other Azure services. Plus, you can also integrate it with services like Twilio for sending messages, SendGrid for sending emails, Kafka, and so on. Uh, it's important to understand the life cycle of an Azure function, what happens when you execute it. So essentially, the very first thing that happens in the life cycle of an Azure function is a trigger, is an event which takes place somewhere which you like to use to trigger your function. For example, it could be as simple as receiving an email or receiving a message on your service bus, or it could be as simple as making a webhook API call. So whenever that event happens, it triggers your function. Once your function is triggered, it executes the function code, and apparently after it finishes the code execution, the output is returned back to the user. It could go back into another Azure service. It could go inside a database. It could mean sending an email or whatever form of output you would expect out of your function. So before we understand some of the challenges that we can face with Azure Functions, there are a few concepts that we should be aware of. To start with, as I was saying in the lifecycle slide, that the very first thing we need is an event that can trigger a function. So there is a specific terminology in functions which is known as trigger. If I go back to the very basic terms, if I pick up a dictionary, a trigger as something that function trigger also does. It essentially defines Azure function can have exactly one trigger. A trigger can have an associated data, which is usually the payload that is triggered the function. Triggers that you might come across when working with Azure Functions include HTTP trigger that triggers the execution of your code by using an HTTP request. Timer triggers to trigger your Azure function and execute your code. The another concept that I would strongly recommend you to be aware of are known as bindings, which are declarative way to make your data available from external services to your function code so that it can be used in the function execution. Bindings are now optional, unlike triggers, where you certainly need one trigger to trigger your function, but bindings are completely optional. Now, there could be two types of binding, input and output. As the name suggests, input bindings are referred to the data that is coming into your function, and output bindings are used to return the output of your function. Now, your function can have multiple input and output bindings. You can use in and out binding directions on your bindings to indicate what type of binding it is. To give you an example, here is a snapshot from function.json file from an Azure function that I have written in C sharp, and you can use any programming framework of your choice. So what you are seeing here is function.json file, and on the top I have declared a binding, which is declaring input trigger, which indicates that my function will be triggered using a queue, and I have provided connection string to my storage queue in there. Whereas the other one is an out binding, which indicates the output that is written from my Azure function, and I have provided a connection to a table where the output needs to go in. Similarly, if you are looking into the function code using C sharp, here is the same trigger and binding information that I was showing in the last slide. Here is how I'm declaring my queue trigger, and this is where my function trigger is defined. And here is where I'm providing the connection strings to my in binding and out binding. There are three pricing plans when you are working on Azure Functions that you should be aware of. Basically, it all starts with consumption plan, which indicates true serverless offering, where you pay for the time the code is executed. This is the default hosting plan when you are provisioning your Azure Functions. The challenge with consumption plan is if you leave your functions running idle, meaning you don't execute your function code for long, it can go into a cold period where it might take some time to warm up the next time when you call your function code, which might not be an acceptable situation in many use cases. To resolve that, what you can do is using consumption plan or utilize premium plan, which basically allows you to use instances I'm sorry, I'm not sure what happened with my network connection, but it did not go down, but looks like there was a flip. I'm sorry about that. Coming back to my presentation, I was talking about dedicated versus consumption plan, a decision that you should make when you are working on Azure Functions. And I was pointing out that depending upon the usage graph or of your function code, you should be deciding whether you would like to go with dedicated or consumption plan. To start with, developing for your Azure function, if you are using Visual Studio, you need to ensure that you have your Azure development tools installed as part of the Visual Studio installation. What that will ensure is that it installs the Azure Function SDK and the Azure Function tools that you will require to develop and test your Azure Functions locally, as well as publish them to Azure. Once you have those installed, you will be able to see the templates inside Visual Studio to start creating your Azure Function project. If you are using Visual Studio Code, there is a separate extension for Azure Functions altogether. Code. Before that, if you install that extension, you would also need an Azure Function Code tools to be installed in your system. Otherwise, you will not be able to locally test or debug your functions using Visual Studio Code. So again, to reiterate, install the Visual Studio Function extension and the Azure Function Code tools with Visual Studio Code if you are a Visual Studio Code user and you would like to develop Azure Functions. Now, it's very interesting. Azure Functions provide a very quick way to provide execution of your function code, and which comes very handy when you are trying to do smaller things like sending an email, or doing image or video processing. But it starts becoming challenge to use these single functions and tie them into workflow. And as you start implementing your workflows using these single independent functions, there are certain challenges that you can come across. What I'm trying to show here on the screen is, let's say if I try to chain three functions, namely function 1, 2, and 3, to execute in a sequence, it's not pretty straightforward to do it using plain Azure Functions, because there is no way I can coordinate between function 1 and function 2 and function 3. They can quite essentially execute independently. There is a solution for that. I can certainly introduce messaging queues in between to ensure that there is no lag in between function 1, 2, and 3, and they can execute uh, every piece of code that I would like to. But again, there are certain challenges. For example, if one of the function goes down, my other two functions doesn't know about it, and they will still keep processing. Whereas that is not an ideal state. I would like my functions to work as a workflow, and if one of the components of my workflow fails, I would expect my whole workflow to fail rather than some of the components keep processing. If we further take it to a pattern like fan in, fan out, it becomes more challenging. For example, it gets more difficult to understand what is happening behind the scenes. It's really difficult to function. By the time you are using independent functions, it's pretty straightforward to start creating complex workflows, functions. There is no state management. That's another problem, because when I was showing you that one of the function fails, the other two functions keeps running. It's because there is no state management. You cannot really store the state of a function execution and pass it to other functions. And you cannot really handle errors properly in the workflows implemented using Azure Functions. And Azure Functions are independently are ideal for a shorter execution periods. My thumb of rule is that I run Azure Functions when I need it only for 5 minutes or so. If the execution time is more than 5 minutes or so, Azure Functions are not a great choice to execute your independent code execution. So to resolve these issues, there is an extension on Azure Functions that you can utilize to implement your stateful workflows known as durable functions. They let you enable stateful functions in a serverless environment. They simplify complex stateful coordination problems in serverless applications, and I will show you exactly in next few slides how that happens. It does provide stateful orchestration of function execution, and I will talk about what orchestration is all about. uh, Before we move further, wanted to highlight that Durable Functions is built on top of Durable Task Framework, which is an open source framework published in GitHub, so you can very well go and check what it all entails to. But that's an interesting fact to know about. So what happens under durable functions is rather than creating plain vanilla Azure functions, you create specific function types. It all starts with a client function, which is not which is similar to any other Azure function. It is basically a triggered function which can be triggered by an event. It could be sending an email, it could be an HTTP call, or whatever type of trigger you would like to use with. Once your client gets triggered, it sends a request to the orchestrator function, which orchestrates the execution of your durable functions, or execution of your workflow, I should say. And inside that workflow, you can execute multiple activity functions to enable your workflow. Within Orchestrator, you can also implement sub orchestrators, and you can execute sub activities inside that sub orchestrator. Apart from orchestrator and activity functions, there is another option to include entity functions, which lets you maintain stateful entities inside your Azure Durable Functions workflow. And I'll talk about that shortly, what entity functions are. But essentially, your client and orchestrator can refer to these entity functions to fetch and maintain your stateful entities inside your workflow. So would like to highlight some of the differences when you are working with Azure Durable Function. If you remember, I was talking about triggers and bindings, and I did have shown an example of C# where I have highlighted some attributes to highlight my trigger and bindings. On top of that, when you are defining your durable function, you also need to define a durable function with a durable client attribute. What durable client attribute denotes is that this is my client function, and this is my entry point for my durable function workflow. Once I define this function, I can go ahead and define my orchestrator function by defining orchestration trigger attribute. Uh, and then finally, I can denote my activity functions using activity trigger. So before we jump into more details, let me quickly jump onto Visual Studio 2022 to show you how you can quickly get started with Azure Durable Functions. So here I'm on the Create New Project screen. I'll go ahead and click on Create a New Project. Since I already have Azure Development Tools installed, I will be able to find Azure Functions template here. But since I have used it before as well, it shows up here as well. I'll go ahead and select Azure Functions, click on Next. Let me give it an example, my test function. I can choose the directory where I would like it to be saved. I'll click on Next. I can choose the .NET framework. Since I'm using .NET platform as the programming framework, I can choose which framework I would like to use with. I'll go with the default option. And now you can choose what kind of trigger you would like to use with your Azure function. As I was showing you in one of my slides, you can use very well triggers like HTTP trigger or Kafka trigger or blob trigger. But for the demo for durable functions, I'm going to use durable functions orchestration. If you are planning to use an entity function, which I will talk in one of our later slides, you can use durable functions entity here. But for demo, let me go ahead and use durable functions orchestration. Earlier, there used to be Azure Storage Emulator that you can use for Azure Functions, running Azure Functions locally, but there is a new flavor of it known as Azurite, which I'm going to use for this demo. I'm not containerizing this Azure function, but if you would like to do that, you can enable Docker, and that will add the Docker file to your Azure Functions project, and you can consume that. And I'll go ahead and create it. By the time it gets created, I did already created a function yesterday for this demo purpose, and this is the boilerplate code that it comes with when I created my durable function. As you will see here, this is my client function where I have decorated it with a durable client attribute. It indicates this is my entry point for my function. And what you will see here is that I'm starting my function one, which is my orchestrator. If I scroll up, I can show you this is my function one, and I have decorated it with our orchestration trigger. Once I trigger my orchestrator function from my client function, it comes here and executes my activity functions. What I'm trying to show here is function chaining, where I'm trying to call 3 activity functions in a sequence. And here is the name of my activity function. And as you can see, that activity function is highlighted with activity trigger. Just to simplify, this is a boilerplate code, and what it essentially is doing is I'm passing a string, and it is logging that string information and printing back hello with that string value. So if I quickly go ahead and run this locally to show you how it looks like, let me run it. So it essentially runs the same Azure function runtime that is used in Azure environment when you publish your Azure functions to Azure. So here, since it's an HTTP trigger, if I go back, as you can see, I'm using HTTP trigger. That's why it's exposing an HTTP endpoint. I can use this, copy that. I'll go here in my browser, and I'll go to my website here. And as we'll see, it does return several URLs. I'll talk about what these URIs are about, but let me go ahead and quick click on this status query get URI to see where my function is. And as you can see, it did return an output, hello Tokyo, hello Seattle, hello London, that you can see it from here. Hello Tokyo, Seattle, and London. I'm executing those 3 functions in sequence. Pretty straightforward. You can get started with writing your durable functions pretty easily. If you are using Visual Studio Code, as I was highlighting, you can install the extension for Azure Functions and Azure Functions Core tools, and you can pretty much do the same thing in Visual Studio Code. It is pretty straightforward to publish using Visual Studio Code. If you would like to publish your Azure Functions, I did try publishing it yesterday and it was quite successful. But if you would like to, you can create a new profile and it will give you an option where do you want to publish it. Since I want to publish it in Azure, I'll click on Azure. It gives me an option whether I want to run it in container, Windows, or Linux environment. I'm going to run it in Windows environment, and it will automatically pick up the subscriptions that I have in my signed in account, and it will then go ahead and give me any of the available functions that I have. If I don't have one, I can go ahead and click on create new here, and I can go ahead and create a new resource group with the supporting resources in my Azure subscription. And I already did that yesterday. I did went ahead in my Azure subscription, created a resource group for this particular demo, and when I clicked on published, it essentially went ahead and created an Azure Durable Function and a supporting storage account too, so that I can run my durable function. When I go inside my function app, as you can see, these are the 3 different functions which come match to my function code here. Here is my function one, which is the orchestrator. Here is my say hello, which is activity function. And here is function one HTTP start, which is my end client function. So and this is my HTTP triggered function, which is the entry point. Here is the orchestration function, and here is the activity function. Let me quickly go to function one HTTP start, which is my entry point. I will go ahead and click on code plus test so that I can test my function and see if it is working in Azure or not. I'll go ahead and click on test and run, and I'll go ahead and click on run. As you will see, like how I was showing you here on my local, where it was showing, giving me all these different URIs, it does returns me URIs here as well. I'm going to fetch the status query get URI here to see where my function execution is. I'll go here and open it up. And as you can see, it did publish the same output as I've seen in my local one. Pretty straightforward. I can certainly go ahead and integrate it with Azure App Insights to log and monitor what's happening in my Azure function and so on. Continuing with our presentation. Since Azure Durable Functions is an extension on top of Azure Functions, it pretty much supports all the programming frameworks that are supported by Azure Functions. For a latest up-to-date information on that, I suggest you to head out to the link that I have provided down below there. Now, you will remember that I was highlighting that there is a storage account that gets created along with an Azure function. And the main purpose for that is when you create an Azure Durable function, it uses Azure Storage as the backend to create what is known as a task hub. A task hub is a logical container for uh, your Azure storage resources, which is then used by your orchestration. Because when you are running your orchestrations in Azure Durable Functions, you need to maintain the state of your activity function so that your activity functions can then interact with each other depending upon the state of each of the activity function. So there are different options. You can share same storage account with multiple functions. You can have multiple storage accounts to be used with different other Azure functions. So what you are seeing here is there is a single storage account which has multiple task hubs which are used by multiple function apps, whereas storage account 2 is only have a single task hub which is used only by function app 3. Now, durable functions under the hood utilizes event sourcing pattern. And as I was saying earlier, Azure Storage is the backend that it uses. And orchestration and activities must belong to the same task hub. You have to be very clear about that. You cannot have your orchestrators and activity functions belong to different task hubs and then you cannot have them interact. And by default, when you're creating your Azure functions, your Azure orchestrators and activity functions are placed inside the same task hub by default. But in case you want to change that, there is an option to change that, but you will not be able to have your orchestrator and activity functions talk to each other then. Interesting aspect of your durable function workflow is it's not pretty straightforward, like the example that I was showing you before, where I was executing multiple activity functions in a sequence. In the most ideal world, you will expect those activities to be executed in sequence, but that's not how a durable function gets executed. The moment your orchestrator gets started, it goes ahead and triggers your activity 1, and then it goes into a sleep mode. And once activity 1 is completed, the orchestrator wakes up, and rather than going directly to activity 2, it goes back to the activity 1 again and sees what's the status of activity 1. Since activity 1 stores its states in task hub, orchestrator understands that activity 1 was completed in the previous run. It goes ahead and executes activity 2 once, and as soon as it starts the activity 2, it goes back again to sleep. And once activity 2 is completed, orchestrator again goes back from the starting and starts evaluating each activity step by step to ensure if it was completed in the previous one or not. And once all the activities are completed, orchestrator goes ahead and completes its execution. To help you better understand that, this is a snapshot of the example I was showing you previously in Visual Studio, where we are executing 3 activity functions in a sequence. So what happens is once your orchestrator gets triggered, it starts from the execution from the very top. It goes ahead and triggers activity 1, and then it goes back to sleep. Once activity 1 is completed, orchestrator starts back from the very top once again. It goes back to activity 1, where it checks the state in the task hub and identifies that our activity 1 was executed in the previous run. It goes ahead and then execute activity 2 and then goes back to sleep mode. Once activity 2 is executed, the orchestrator wakes up and starts the execution once again from the very beginning. It checks that activity 1 and activity 2 were completed in the last run as per the task hub. Then it goes ahead and it executes activity 3 and goes to sleep mode. Once activity 3 is completed, Orchestrator starts again from the very top and evaluates the execution status of each of these activities from previous runs. And once it identifies that all the activities were executed, it returns the output and exits. Now, error handling can be implemented in your orchestrator and activity functions using the programming language constructs that you are using. For example, if you are using C#, you can use the traditional if-else constructs inside your durable function and try catch for your durable function error handling. You can, when you are running your Azure activity function, it returns a function failed exception whenever there is a failure. So that is a specific exception that you can catch inside your orchestrator to find out why your activity function failed. Here's an example from C#. As I was saying, you can use the same try catch constructs similar to any other C# program. You can also implement an automatic retry policy to call your activities and sub orchestrators to come out of transient failures. And you can also use a durable timer to abandon a function call if it's taking too long to complete. I was showing you several URIs when I executed my durable functions. Those are basically used to perform management tasks on your orchestration entities and task hubs. You can perform activities like you can start orchestration, you can get the status of your orchestration instance, you can purge instance history, you can raise event, terminate instances, you can manage your entity functions using those REST URIs. The things that you should be aware of is each of those URIs or API calls take 3 parameters: task hub, connection, and system key, and they can return one of these response codes. They either return 202, which means that your request was successful. If it was not, then it will return HTTP 400 bad request. You can check out the link I have provided there for more details. Moving further, there are different patterns that you can implement using durable functions pretty easily. This is what I'm showing is a function chaining pattern, which is similar to the demo that I have given you, where I have executed 3 different activities in sequence. So under function chaining, you can execute your activity functions in a sequence. You can certainly have your state and data stored in a state store or in a database in between the function calls. And this is a snapshot of the example that I was showing you before to highlight how you can have your function chaining pattern implemented. You can also implement fan out, fan in pattern using durable function. Fan out, fan in refers to the pattern of executing multiple functions in parallel and then waiting for all of them to finish. Often some aggregation work is done on results returned from your patterns which are run in parallel. Here's an example of the code that you can use. You can run a for loop inside C# code to execute your activity function multiple times. And then you can go ahead and wait for all the tasks to finish. And once those are finished, you can finish execution of your durable function. You can implement async HTTP API pattern where you can have long running actions triggered by an HTTP call, and then you can redirect the client to a status endpoint that the clients can keep polling to learn when the operation completes. And here's an example of that where you can keep calling the status URL to find whether your status is completed or not. Once completed, you can get the output and continue your execution. You can also utilize a monitor pattern where you can have an Azure Durable function which keeps monitoring an event, and once that event occurs, it can go ahead and execute the next steps in the workflow. Here's an example where it's waiting for a job to complete. Once the job gets complete, it sends an alert. There are many times situations where you need human interaction inside your workflow. For example, you would like to approve or escalate a process, and you can implement that pretty well using human interaction. Here is a code example for that, where you can wait for an external event. Entity functions, as I was mentioning earlier, you can read and update small pieces of state inside your durable function workflows. Those are known as durable entities. You need to utilize a special trigger type called entity trigger, and you need to highlight that inside your code with durable entities. Here is an example of how you can use a durable entity inside a Azure Durable Function. And the point to be noted here is you have to highlight your entity function using entity trigger attribute, which indicates it's a stateful entity. And then you can define different functions where you can add or fetch the value of that state information inside your durable function. Durable HTTP, sometimes there are situations where your orchestrators cannot do IO directly. In those cases, you can utilize durable HTTP, meaning you can call HTTP APIs directly from your orchestrators, which for which I've shown an example here. Now, there are situations where your orchestrator functions can never end. They need to keep running infinitely. So you can implement it using a function known as continue as new to trigger your eternal orchestrations. Sometimes you might also need to run background jobs as a single instance or a singleton instance. You can implement that as part of durable functions workflow as well. And I've shown a example for that. When you're working on durable functions, one of the challenges you will face is how you need to version your durable functions when you are changing activity or entity function signatures, or you are changing your orchestrator logic. There are three strategies you can deal with versioning. First of all, you can do nothing, which is certainly not recommended. Secondly, you can stop all the in-flight orchestrator instances and then update your latest version, or you can do side-by-side deployment. So you can opt for that. I have provided a link down there. You can check more on the limitations that comes with orchestrator functions. The one that I would like to highlight is that orchestrator function can call only deterministic APIs. A deterministic API is an API that always returns the same value given the same input, no matter when or how it is called. And you should avoid APIs which return current date or time, GUIDs, random numbers, and so on, as in all those cases, the value can change on each API, each replay. Here are some more resources for further reading. You can check out the actual Azure Functions documentation for reading more on Azure Functions. Specific information on durable function is provided on the second link. The different patterns that I touched upon in the presentation are covered in durable functions patterns. There is a YouTube channel that is run by Azure Functions team, which provides good information on Azure Functions. Do check that out. And as I was mentioning, durable functions are based on Durable Task Framework, which is an open source framework. You can check out using the link there. If you have any questions, you can post it on the comments, and I'll go ahead and certainly check it out and get back to you. If you would like to connect with me on LinkedIn or Twitter or any of the other means, you can scan the QR code and get connected with me. I would be more than happy to talk to you and get in touch with you. If you would like to get a copy of these slides, you can scan this QR code and download a PDF version of these slides for your later reference. And with that, I would like to end my presentation. I know I ran a couple of minutes over the time, but thank you once again for joining us tonight. I appreciate you all joining. Thank you once again.